Hello and welcome to another edition of On the Shop Floor. And this time I am at one of the brightest and most promising startup, you can call it, or a technology company that is now beginning to deliver to the Indian Armed Forces. It's called Sagar Defence Engineering, and the man leading the initiative against many odds over the past nearly 10 years now when he founded the company is Nikunj Parashar.
Thank you, sir.
He is the founder of Sagar Defence, and of course he has a team that looks after the new products, innovation, research, development, and they are mainly into autonomous marine systems, not just for the Indian Navy but also for ONGC and for other users. And apart from that, two other armed forces are also now looking at his products. Some of them have been inducted already. But it's a company that was born out of the Ministry of Defence IDEX program, and something that the success story can be an example for innovative startups that are looking to break into the defence ecosystem. So thank you very much, Nikunj, for having us here and telling us what you're going to do and what are you doing. So give us a brief idea of how you started and why you started this.
So I'm a sailor. I sailed for 16 years out at sea, and the reason to start off this was, first I was trying to discover myself, what I want to do in life. It was never about the money. And coming back to India after my quitting job in Denmark, I realized what Kasab did to Mumbai. And being a Mumbaikar and a navigator, I understood that the choke points which are there on the high seas, it's not easy to cover all of them. That led to forming of having certain vessels out there which could be eyes and ears for you on the high seas. And that's what led to USV. So I asked my dad, and the business I was with him, give me 8 years.
Okay.
I proudly say it took me 7 days and 11 months to do the first prototype. So I did it before 8 years.
Okay.
So it was the need for autonomy. It was need to keep our sailors away from harm's way and place those eyes and ears so that Kasab doesn't happen again.
Great. So you're building not just surface autonomous systems but also underwater, and also you started off with drones flying in the air. Obviously drones fly in the air. So what was your first kind of a customer when you started off? You said Navy or the police, Marine Police, whatever. But what was your first successful order?
I think the first successful order came much before Sagar Defence was formed, sir.
Tell us the story.
So 2011 I came to India, and my dad runs a small ship repair shop, I would say a workshop. And he got a radio control target board repair and refurbishment order.
Okay.
And it was with the Naval dockyard, and I went to the dockyard and said, look, it's a repair and refurbishment order, and I'm ready to do a brand new platform for you across.
Right.
Navy did a very strong hand holding because the difference between L1 and L2 was way too huge. We were L1 at much lower price.
Okay.
And it was also difficult for the Navy to understand whether we will be able to do the job or not. So I asked question that, Nikunj, you're starting up new, this could really derail you. I said, no, don't worry, I'll be able to do it. So we did the first radio control target boat in 2013, and that's really caught even my own attention. I realized the potential as what I'm thinking across of doing in my life. And that first project went on for trials till 2015. When the trials were completed in the month of April, in May 2015, I formed the first company.
Excellent. So it was born out of a repair product, refurbishment product, but obviously you were thinking all the time to do this. Now what is this where we are standing here? This is one of your key projects that you've got from the Navy. Just explain what this is.
So recently, if you would have read about, certainly you are aware that the Honorable Raksha Mantri launched the autonomous surface vehicle craft from Mumbai all the way for Thoothukudi.
Right. Thoothukudi is down south.
Down south, right. Yeah. So we did the Sagar Mala Parikrama, what's written here also. And this was a challenge across to not only for the India, but to the world also, to show that India can. And a small company like us, which is thinking about this capability, Navy ensured a lot of trust on us in this. So this is an autonomous marine surface vehicle, capable of doing speeds above 50-55 knots, having a range of over 400 nautical miles, could operate over 48 hours in the open oceans. And we have vessels called FICs and ISVs in the Navy. And these are, so this is 13 meters, though around 15 to 17 meters. So in a much smaller size vessel, I call it Chota Rocket, Bada Dhamaka.
Yes.
That's what she is.
Okay.
And she comes with an SRCG 12.7 mm gun with solid state radars. A fully autonomous craft built not only by Sagar Defence, but I would say built by Indian Navy under the IDEX program. Without the support of the forces, I don't think so we would have been able to see this day.
So what is the main function that you would like this boat to do for the Navy? What were they looking for?
So they were looking for ISR operation, intelligence, surveillance and reconnaissance operations. And the biggest challenge, no Kasabs coming in.
Right.
So this would act as your eyes and ears on the high seas. And you may place frigates, but still the pockets are going to be there. This takes care of the fatigue because
So the gaps can be filled.
gaps can be filled. It doesn't have human on board, so the fatigue is not there. The only thing it requires is a fuel. And if you keep it long hours of period of time just hovering in an area, she could do operations of over not 48 but 72 and much above than that.
Right.
And at a point of a push of a button, she's ready there for the kill.
Okay, but how do you recover it? Suppose you've sent it from the shore, and then you get the idea that the fuel is running out, or you have that endurance thing, and you just bring it back on the autonomous machinery, autonomous system that you have.
So it's a fantastic question. This vessel is a very, very smart platform. We don't know to tell her that when the fuel is going to get over.
Right.
We don't tell her that how to come back to the own place. Once you have told her what is its mission at the end of the line,
When you punched it in.
then the vessel takes care of itself.
Okay.
So it will notify you that, hey, look, I am on my low fuel side. I'm going to come to a designated position of fueling. The vessel arrives there. You go ahead, you fuel her up, and she can come back into the dock itself.
Smart. So can we take a look at this?
Absolutely. Why not? Now we are removing everything in.
Sure.
So prototype life is done.
Okay.
So this is, so as we were talking about small chipsets,
Right.
the autonomy is in semiconductors with integrated software.
Sure.
Now the same thing from there, which is in a drone or underwater vehicle, goes in a platform size of this size. This weighs around 150 kgs because shock tests and all that is required.
Sure.
So it integrates here. Now, as humans, how we are, for us as a system, everything is a payload. The boat is also a payload, and the system fitted is also a payload.
Right.
So it's a small chipset,
Right.
which hardly costs 25,000 bucks, if I would say. But then when you start doing it in a military grade product, you have to turn it into a system which is hardened, rugged, and capable of warfighting capabilities.
Sure.
That's what happens here across.
Okay.
Now this, like a black box, is fitted on the platform. Everything is a payload to us. That means hull, engine, everything is a payload,
Right.
like a human body. Then what happens is, depending how your eyes, ears, nose is, you build up your perceptions, right? The same way, depending on what kind of sensors I have on board, how the engines are performing, the system starts building its perception. Then this perception will define your behavior. So that means on your perception, you have your upbringing cycle. It's the same way the platform decides the behavior of what task it can carry out. And that eventually leads to carry out your final task. So the beauty is we have a bottom approach. In that scenario, on day one, we can tell you on our simulators, hey, look, you have a good platform, but this is what it can do max.
Right.
It cannot do more than that.
Yeah, sure.
So we under promise, over deliver. And that is one policy we have been following from day one. And it's not us, it's maths and physics which tells us to do across.
Yeah, exactly. So, like you already said that you've built this to be a system both manned and unmanned.
Yes.
So this people can sit here, they do it. But the one that did this voyage, Sagar Parikrama, was unmanned.
This platform, this is the platform. It was completely unmanned.
This is the same
This is the same platform. We went for Sagar Parikrama. Now I'm getting it converted. So it was completely unmanned. We were team out at sea on a separate vessel with the Navy, and she was carrying out all its maneuver completely. And then finally she entered harbour at Tuticorin.
Excellent. It's got cameras, sensors.
2D radars, 3D radars, optics, 360-degree optics, non-line of sight communication.
And this all comes back to the
Command control
base
center.
station command control center.
Yes.
Which is again developed by you.
Yes, it's lying outside
Right.
a factory over there.
Correct. Yeah, we saw something of
a
that.
container there.
Container.
So it again comes back to us. So if you see, as I said, by design we are hardware, software.
Right.
We went on to become platform builders, and then we went on to become system integrators also, because as a small startup, it was very difficult to go to a third party and do that. And when you go for proprietary APIs, it's expensive. So सरस्वती की पूजा करते हैं और उसी पूजा की वजह से खड़े हो गए.
बिल्कुल, लक्ष्मी भी आपको वरदान दे रही है. Come. So the Mercury engines.
These are Mercury engines. These are outboard engines. Outboard engines are not manufactured in India.
Right.
So we brought them from US. This is 1,000 horsepower over there. With
3 of them.
3 of them.
Okay.
So they push it above 55 knots.
Speed is much faster than anything
yeah,
else.
standard across. And we had a naval officer post the completion of the trials. He boarded us and he said, "Can I drive it?" I said, "Why not?" So when he went up on his speed, he says, "I'm the first man in the Navy to go this fast."
The ships don't go that fast at all.
Don't go that fast. We got this planted by Karavir Singh, sir.
Okay.
And it come.
And he came, yeah. That time he was very supportive of all.
He was very supportive.
Very supportive. This is your initial working.
Initial working is where we started off from 1200 square feet. We came here.
Right. And these are the various
drones which are going on. This one goes. So this is the spotter. This goes with the Indian Navy right now.
Right.
And being used by the Indian Navy.
It was used in the Gulf of Aden operations.
Gulf of Aden operations, as well as recently off in the Park Strait between Sri Lanka and Indian Navy, where they caught 600 kgs of meth.
Yeah.
Platform was used. She was under 8 hours of operation.
Wow. So endurance is around that much.
So this flies for 2 hours.
Okay.
Then you land, change the batteries, and it flies in.
And then
this is nuclear detection. So this has a nuclear detection, radiation detection payload.
So
again with the Navy, yes, and NBC product. Again with the Indian Navy, with the Army, these units are designed with the help of DRDO.
With the
DRDO. The payload was developed with the DRDO.
Okay. And these are various
the various platforms which you have been building in. So everything is built in-house from scratch.
That's I think your strength, that you're not going out anywhere.
Yeah. If you see a monocoque design like this, now this is 8 years back. This was the first piece we designed.
Okay.
But to get a product single like this, it's very difficult. Extremely complicated. How do you do that in carbon fiber?
Correct.
So this is our own proprietary, and we have been doing this. This helps us to bring efficiencies, especially
for airflow,
airflows and airframes. In terms is if you have to join 2 carbon fiber rods in a trihedral shape, you have to use aluminium.
Correct.
But aluminium with carbon fiber is very complicated, so it can break.
It can't gel into each other.
Correct. So then we did this coupling, and this coupling is in a single mold. We took it out.
Wow.
So it's very complex. People don't do this. They say it's. We had people saying that, why do you do this? It's expensive. So we laughed at it. So yeah.
But now you know why it is. Yeah.
And from there, this is the finish it comes to.
Okay.
Or if you look at these frames, so people go out and buy. We build it.
Oh, you build it here. Yeah. And so light.
Light. So we do our own stress test, our modulus.
And yeah, exactly. And very strong.
Very strong. So when you look at the strength, okay. May I use kar lo ise? Huh? So you hold this?
Yeah.
Put it down, sir.
Okay.
Put it down, sir. Now stand.
Okay. Yeah. Yeah, that's right.
This is going under construction right now, production.
So you already tested it.
So if you see, the uniqueness is when you say no, it's built like a feather, but meant for a tank operations. This thing was never being done in the country before, and we thought if we are going, it may not look beautiful,
right?
But it's
rugged.
Rugged. So that's what rugged means across.
Exactly. Useful. Very useful.
So these are different frames.
These are again frames there.
All our AUVs and everything is built on these CNCs machines across.
And these are very state-of-the-art machines.
State-of-the-art. Germans and Americans across. We have not compromised.
Right.
So if you talk technology and if you talk about space grade and military grade, and if you compromise on manufacturing, then you're done.
Then you'll never get through.
Yes.
So what is this process going on right now?
So right now, I think it's one of the drone part, which is an end coupling.
Oh.
They are manufacturing in.
So from here it will come out.
From here. And this is something is a lot of people say that cost goes high. We say no, it's customization.
Correct.
Customer pays you, invest in the machine and do that. Plus, all my engineers are trained to use this machine.
Okay. So it's not
just a single operator. So everybody should know how to use it. For a matter of fact, if I have to come and see and if I know few operations of this machine, so that's how it is.
When you bought them, there was only one use, right?
Yes, there was. So there are around 50 such machines here in Pune, they say.
Yeah.
And within 7 days, the hub fell down. So Philips guy came running and said that how this happened. I said, oh no, we are putting them into multiple use.
Right.
He said, oh, generally people don't do that. They only put them through one process. So, and in us, we have a policy that everybody should know how to use a machine. For me, for example, I should also know. So, upload, use, run, keep it running.
And obviously, you do, the training is done on
In-house, yes. So, we do in-house trainings. We maintain the calibration standards. We have given their AMCs. We are very thorough, because if machines don't perform, then it's going to affect the end product also. So, we are very careful about it. So if you can pick up any of the engineer from here and send them to operate, they are going to operate it.
Okay. So let us see your software.
Sure, sir.
What revolution the drones have brought. Huh?
Oh, it's scariest of the revolutions, to be honest.
They're going up, right?
They want electronics.
Achha, that side. Okay.
Yeah. ये चालू है क्या? So this is easy.
I know, this is easy.
Yeah, this is easy.
This is your electronics lab.
Yeah, this is electronics. So all your battery packs, BMSs, PCBs, the embedded system designs, and the software design happens across in these two labs.
Okay. So you get the cells.
We get cells. We
and
import
then,
the cells.
Put them into. So these are your battery that you are creating, and this is the cell you get.
This is the cell. Yeah, this is the cell which we
import.
Yeah, we import just the cell.
Okay.
And on that cell, then the whole battery pack assembly, everything happens. Okay. The battery management systems, even the nickel strips which we were talking.
Yeah.
We go to the thickness level of what kind of nickel strip we want, what should be the thickness of. Yes.
Okay.
So that takes care of the temperatures and the thermal efficiencies also.
This is for all your drones. And
all our drones, even for our hybrid boats also. Okay. So we do electric USVs also.
I see.
So in the electric part also our battery system goes in.
Right.
So that's how it is designed in house.
Okay. And these machines of course have been imported.
Yeah, this is all Japanese which you're seeing in pickup place.
Correct.
That's where the design engineers they sit in, all with different across, and it's the lunch time.
Correct.
But what you see here with these engineers, what you're seeing in is how do we hire them?
Right, that's what I was interested in, because I'm seeing, people working diligently everywhere, and I'm sure you pick them with a lot of care and diligence.
We hire from Tier 2, Tier 3 cities.
Okay.
We don't go to IITs and these places. We hire from small towns and small cities. Important is for us is more than the knowledge or the talent is attitude.
Okay.
It's important because attitude brings in the fire in the belly, and plus the upbringing is very strong from the sense. So they believe in giving back, being as a family member, understanding those core values, which at times you really find missing in these metro colleges, commercial colleges. So we really do that. We travel distance to Haryana, in outskirts of Maharashtra, the really end and central Maharashtra too, and that's how we hire people in.
Excellent. And how many employees now you have?
We have 154 as of now, and possibly by March we'll be 300 plus.
Oh, you're scaling up.
We are scaling up. This is the time to go up. I think God has been kind. It's just not pure hard work, but I'd say there's Rab ki meher hai.
Of course, Rab ki meher nahi ho to kuch nahi hota hai. But it's been nearly 10 years now as a company.
As a company, yes.
It's next year will be 10 years.
Next year will be 10 years.
Okay. Which month was this?
May is when we started off.
That's nice. No, it's good to know the HR policies. And I think the fire in the belly is from your own example. People would get inspired. I'm sure they're coming in here. I wish you the very best in the near and the long-term future.
Thank you so much.
And BharatShakti is always there to promote, propagate, talk about companies like this, which are going to be the future of the Indian defense ecosystem.
Thank you so much. Pleasure.
That was Nikunj Parashar of Sagar Defence Engineering. As I mentioned right at the beginning, very promising company doing cutting edge technology for mainly started off for the Indian Navy, but also now graduating to the other two forces, and of course civilian applications or use going forward. I am Nitin Gokhale, and with me are my colleagues Pawan and Aditya, who are on the camera. Thanks for watching.